Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we'll be focusing on redox reactions, and then you will be doing our galvanic cells. You might have started or finishing the topic at your school. So it's important that we know it's part of paper 2. And then we are saying it's still 150 marks for paper 2, and we still have 20 marks that are allocated to multiple choice questions, 130 marks for structured questions, and 150 is total. Now, without wasting time, let's look at your ATP. You will know, you will have started, you will have done your electrochemical cells, your electrolytic cell, which is part of these redox reactions that we are doing. I know that you have started redox reactions in grade 11. So now we'll be taking them to the right place. We want to check in grade 10 as well. You have prior knowledge. You are not coming here empty. There's something that you have done before. You have done in grade 10 what we refer to as pure substances, which is your elements and compounds. And you will see, as long as you are dealing with this topic, we'll be referring to substance. So when I say a substance, it means I mean element, I mean a compound, or an ion. So I'm just adding the third thing there to say when I say a substance. So there are three things that we're going to deal with here. It's an element. So you'll find an atom. You'll find compounds. You know, when you join them together, you form compounds, and then you have ions as well. So it's important that you know what is an element, you know what is a compound, you know what is an ion, because that will be the focus of our lesson. Hence, we're starting with the definition, a grade 10 definition that defines an element as a substance that cannot be broken down into simpler substance by chemical means. For example, if you are having, say, magnesium, is an element because you can't break it down. However, when you say a compound, we're saying it's a substance that consists of two or more elements. When you have two or more elements that are chemically bonded in a specified ratio, we call that a compound. For example, you can have what we call copper chloride. So copper chloride will refer to it as a compound because it has substances that are two or more substances that are joined together, the elements that are joined together in a specific ratio. So we are saying we have elements, so we're going to deal with elements, more especially the metals and your non-metals. I think you know the metals in the periodic table, your non-metals as well. So we'll deal with compounds, which are just the elements that are joined together in a specific ratio. And then you have done as well in grade 10 the naming of these compounds. You will remember you had your sulfates, your nitrates, and all that. The table of negative and positive ions, which is something that you have done in grade 10. This is just to show you that prior knowledge is important. We're always building a house. We always start with the foundation. So always remember this foundation will be very important for you to understand this topic. Now, I want to remind you about ions to say, you will know that when we talk about an atom, I will use, for example, sodium atom. When we talk about a sodium atom, it has what we refer as electrons. It has what we refer to as protons. It has what we refer to as neutrons. And remember, electrons, we're saying these are negative charges. So we have negative charges, which is our electrons. We have our positive charges, which is a proton. We have neutrons, which has no charges. So you will know that sodium S number 11 in the periodic table, it means it has 11 electrons and 11 protons. Remember, electrons, we said it has 11 negative charges and positive 11 positive charges. Hence, we write sodium like this as neutral. So we're going to show how ions are formed because it is these ions that are going to, most of the time, accept the electrons. Remember, if you are an ion, it means it's either you have more electrons or you are electrons deficient or you are running short of electrons. So we're saying an atom contains an equal number of negative and positive charges. That's what I'm saying. To say when you see sodium like that in the periodic table, it's neutral. So it means it has 11 electrons which are negatively charged and 11 protons which are positively charged. That's why 11 and 11, they cancel one another. That's why we're saying it is neutral. Now, if an atom has fewer electrons than normal, then it gets a positive charge. For example, you have done ionic bonding in grade 10, where you said sodium can lose an electron. When sodium loses an electron as a metal, it will now become positively charged. So when we say a positive charge, you know that we have electron deficiency, meaning that we are running short of electrons. So when you see sodium plus, you know that it has lost 1 electrons. But if I write for you, for example, magnesium 2 plus, you will know that that magnesium has lost 2 electrons because they are no longer equal. Because when it's neutral, it means the number of electrons and protons are equal. So it's important that you understand these electrons because that's what we'll be dealing with. Now, if it is magnesium 2 plus, we're talking about now an ion. And this ion is a positive ion. And I think you remember that a positive ion, we call it a cation. So I just write cation with a positive there so that you remember that a cation is a positive ion. A positive ion is formed when a substance loses electrons. I told you that a substance can be an element, can be a compound. So we are saying that a cation shows that we have lost an electron. When there is a 2 plus, it means we have lost 2 electrons. When it's a 3 plus, it means we have lost 3 electrons. And you must understand the meaning of a negative charge. For example, I can write chlorine minus. When I say chlorine minus, I'm saying that chlorine has gained an electron because it's minus 1. When I say, for example, you have done sulfates as well, SO4, 2 minus. So you can see that it has in excess of 2 electrons that are sulfate ions. So you must be able to understand the meaning of a cation, which is a positive charge, and an anion, which is a negative charge, because we'll be dealing mostly with those, and it is these charges that we'll be referring to. Now, if an atom has more electrons than normal, we said it gets a negative charge. That's what I was saying. And when it has a negative charge, we refer to it as an anion. You can see an anion to say, you can just say a negative ion, a negative ion. N, you can look at it as a negative ion. N ion is a negative ion. It means that we have more electrons. And then a cation, which is positive, it means we are running short or we have electron deficient. So we're saying an ion is positively or negatively charged, as I indicated, that when you have a positive, we call it a cation. When you have a negative, we call it an anion. And we're saying, for example, sodium ion that I gave you is sodium plus. Magnesium ion is magnesium 2 plus there. So I think you will be asking yourself in that way to say, how do we know whether it will be a plus 2 or a plus 1? For example, sodium. So this depends on the group number. On the next slide, I'm going to indicate to you how these charges are formed and which group will form positive 1, positive 2, positive 3, and plus or minus 4 or minus 3, minus 2, minus 1 in terms of the charges or the ion. Already, the main thing on this page is that we have a positive ion that we get when electrons are lost. We have a negative ion that we get when electrons are gained, when we have more electrons than expected. For example, I've showed you the chloride ion that it shows that already it has gained an electron. So it's important that you have that information with you and it will help you as we move forward. Hence, I'm coming to this slide to explain, to say when you look at your periodic table, you are having group 1, group 2, group 3, group 4, 5, 6, 7, up to group 18 elements. But now I chose this because this will be able now to help you in terms of knowing which group will form positive 1, which group will form positive 2, positive 3 in that order. So you can see that group 1 elements, they are metals. Metals are more likely to lose electrons. So hence group 1 elements, they form positive 1, which means they can lose 1 electron. They are more likely to lose 1 electron. Group 2, positive 2, which means they can lose. Remember, we said when you lose electrons, you have more protons, which you have more positive charges. Then when you lose 2 electrons, you'll have positive 2. And then when you see positive 3, you see that there we have lost about 3 electrons, which happens with aluminium, which is a group 13 element. It's a metal of a specific metal that I want to mention there, so that you know that in group 13 where we have aluminium, aluminium can lose 3 electrons because it's group 13. But look at group 14, they can either gain or lose electrons. Here you will find carbon. Remember, carbon is a non-metal, but it's a good conductor of electricity. So that is what makes carbon very special. I know you were busy dealing with carbon when you were doing organic chemistry, and then you are more likely to understand that a carbon can share 4 electrons around it to form bond around itself. Now, when you go to group 15, you are having minus 3 there. you will get more nitrogen there. So we are saying those ones, they can gain, they are nonmetals. They are more likely to gain 3 electrons, the group 15 elements. And then group 16, where you have more oxygen and the likes, you're more likely to gain 2 electrons. Remember, these substances that are having the negative, if you look at them, they are more electronegative, which means they are able to pull electrons towards themselves. So group 17, when you have the halogens, remember we have bromine, we have chlorine and fluorine in that random order. And then we are saying group 17, they have a charge of -1. So it's important you have done the oxidation numbers, which we're going to talk about them now, and then you are able to check. It means immediately when you check the group where the element belongs, you are able to know how likely is that supposed to lose or gain electrons. Now we're saying metal and materials, you've done that. You've done metals, you've done metalloids, you've done non-metals on the periodic table. And we are saying metals are good conductors. They have between 1 and 3 electrons in the outermost energy level, and we refer to those as valence electrons. So you know that these have 3 valence electrons, and if you have 3 valence electrons, and these are very, underline that one, very loosely bound. So it shows that if you have electrons with you, but those electrons are not tightly bound, it's easy to lose them. That's why it's easy for metals to lose electrons. But we have non-metals, which are poor conductors, and they contain between 4 and 7 valence electrons. So these ones are more likely to gain because the electrons are firmly bound, and we call them insulators. But we have an exception, as I told you already, to that rule that non-metal does not conduct electricity, which is graphite. Your carbon is a non-metal, but it can conduct electricity. You'll see when you do electrolytic cell, you'll be using a lot of carbon as your electrode there. So the graphite that we use in pen cells as well, that is your carbon. So you got to know that we have a carbon which is very special because it's able to conduct electricity, but it's a non-metal. Now, as we move, I just wanted to remind you this. There is no paper 2 without a periodic table. It's very much important that you understand the meaning of this periodic table, because as I indicated, you have group 1 elements there, which is your alkali metals, group 2, which is your alkali earth metals, and you have your transition metals, which are these metals that you see there. They are transition metals. As we move now to semi-metals that are in yellow there, and on the right, we have non-metals. So the non-metals, you are more likely to find them on the right-hand side of the periodic table. The metals are on the left, and in the middle here, we're saying we have transition metals, and then I showed you the semi-metals there. So it's important that you understand the periodic table, and we're saying these metals are more likely to lose electrons because the electrons are not firmly bound, they are loosely bound. But when you go to the non-metals, they are more electronegative, meaning that they always want to pull. They have a strong pulling effect on the electrons, so they are going to be negative. They are most likely to gain electrons. So always remember this, and it will help you when you have a metal and non-metals. Now, in grade 11, you have done redox reaction. Now, redox reaction that you have done in grade 11, you were able to explain the meaning of oxidation number. You were able to assign oxidation numbers to atoms in various ions and molecules. And then you were supposed in grade 11 to describe a redox reaction, which is a reaction which involves electron transfer. So you can see the whole day we'll be discussing an electron. It's either we gain electron or we lose electrons. So this topic is all about loss of electron and gaining of electron. So we're going to do that as well. And we're saying the oxidation numbers will always change. When there is a loss of electrons or gaining of electrons, we are saying that the oxidation number will change. So it's important that you have this foundation of the oxidation numbers because they're going to help you as we answer the question. We're saying you must be able to identify a redox reaction. If we give you a reaction, you must be able to say this reaction is a redox reaction or not. And you must be able to know what is oxidation, what is reduction, what is reducing agent, what is oxidizing agent. These definitions, they are simple and very short. So I would like you to always remember them when we do them now forever. When you write your exams, you are able to do that. The last thing, you must be able to know that we have the table of standard reduction potentials. Remember, you have table 4A and table 4B. So it's very much important that you have that understanding of how to utilize these tables, and you must be able to balance redox reactions using this particular table of standard reduction potential. Now, in terms of what you need to know, or some of the things that you will have covered and done in your previous grade from grade 8 to grade 11, you will have by now what is oxidation. Remember, we define oxidation as loss of electrons. Loss of electron, we call it oxidation. This is a most important slide because in terms of definitions, you will be able to remember all the definitions and we must be able to move together. So we're saying loss of electron, we call it oxidation. Don't forget that. What is reduction? We're saying gaining of electrons, we call it reduction. Gaining of electron is reduction, loss of electron is oxidation. Now we are going to use the oxidation numbers as well to define this oxidation and reduction, so that you are able to see that when we have a decrease in the oxidation number, that must be reduction, but when we have an increase in the oxidation number, that must be oxidation. So oxidation happens when we lose electrons. For example, if I was to give you, say, a zinc becoming zinc 2 plus, it means it's losing 2 electrons. So you will be able to see that oxidation, in terms of oxidation numbers, remember zinc alone has an oxidation number of 0. So increase in oxidation number of zinc from 0 to 2, that is oxidation. So oxidation is increase in oxidation number. In our grade 12 language, we are saying loss of electron is called oxidation. So we can say define oxidation in terms of oxidation number, or define oxidation in terms of electron transfer. So you're able to know that oxidation is loss of electrons, or you can say it's an increase in terms of oxidation numbers, it's an increase in oxidation number. The same applies when you are dealing with, say, you have Cl2 gaining 2 electrons to form 2Cl minus. So you can see when you have Cl2, you can see that this is 0, but the other one is minus 1. So what is reduction in terms of oxidation number? It's a decrease in oxidation number. You can see that Cl2 has oxidation number of 0, but 2Cl minus has oxidation number of negative there. From 0 to negative, we have decrease. So decrease in oxidation number, we call it reduction, but increase in oxidation number, we call it oxidation. So don't forget that loss of electron is oxidation, gaining of electrons is reduction. So I was emphasizing that. But now you can take it further to say this one that is losing electrons, that is undergoing oxidation, we call it a reducing agent. So I'm adding the RA there to say what is a reducing agent. You are simply saying a reducing agent is a substance. You are simply saying a reducing agent is a substance that undergoes oxidation, or is a substance that loses electrons. So the main thing there on the reducing agent is the issue of the substance. You are simply saying a reducing agent is a substance that loses electrons, or a substance that undergoes oxidation, or you can say a substance that is oxidized. So this mnemonic is there to help you to remember that we have loss of electron, which we call oxidation, and this substance that undergoes oxidation, we call it a reducing agent. So how many definitions you have done so far? We have defined what is oxidation. We said it's Leo, loss of electrons is oxidation. So Leo, don't forget. And reduction, we are saying is gaining of electrons. Now we are defining a reducing agent as a substance that undergoes oxidation, or a substance that loses electrons. In the same way, we can define a oxidizing agent, saying gaining of electrons, we said is reduction. And then what is an oxidizing agent? It must be a substance. Don't forget, you always start by saying it's a substance that undergoes reduction, or a substance that gains electrons, or the substance that is reduced. So these are the definition of oxidizing agent. So please don't forget all these definitions because you will be able to collect your marks. So we've done the definition of oxidation, reduction, we've done the definition of a reducing agent and oxidizing agent. Now we are left with the definition of what is an anode. You must know what is an anode, what is a cathode. So we're saying an anode, you can see from the name ode, it ends with ode. So that means it's an electrode. We say an anode is an electrode where oxidation occurs. An anode is an electrode where oxidation occurs. A cathode is an electrode where reduction takes place. You can see I didn't say a cathode undergoes reduction. I say it's the electrode where. So I'm referring where there is a cathode, there will be reduction because there is a mistake that you make, learners make, and to think that a cathode itself it undergoes reduction. But we are saying where we have a cathode, a reduction will take place. So the type of reaction that takes place where we have a cathode will refer to that as a reduction. Where we have an anode, the reaction that will take place, it will be oxidation. Hence we said an ox, for you to remember, an ox, or we say red cat. An ox or red cat, to remind you that where there is anode, the reaction taking place is oxidation. Where we have a cathode, the reaction taking place is reduction. So please don't forget, we'll have a lot of these mnemonics, so know them and let them remind you all the time how to remember all this. So the issue of oxidation numbers, which is what we have done in grade 11, we'll look at it as well so that you are able to answer questions from grade 8 to grade 11. You have talked about electrolysis, where you are using electricity to break down organic molecules. So we'll look at that, and then lastly we'll do that electrolysis of copper chloride. I know you might have done it in lower grades, but we'll still be able to do it here. Now, the definitions, which I'm done with this slide because I've already indicated to you that loss of electron, we call it oxidation. I've already indicated to you that a reducing agent, which is your Ra now, it's a substance that undergoes oxidation, or a substance that loses electron, or the substance that is oxidized. Now, you understand that one. As well, we are saying gaining of electrons is reduction, as we said. And we are saying the oxidizing agent is a substance. Don't forget, a substance. It's a substance that undergoes reduction, or a substance that gains electrons, or a substance that is reduced. So these mnemonics, I'm telling you, they will help you in remembering all that. Let's look now at this. We are having a substance that loses electron. We say it's oxidized. Remember, oxidized is it's like you're saying increases in the oxidation number. When you say oxidized, saying the oxidation number increases. Maybe you're asking yourself, how can I lose and increase at the same time? Remember, you are losing negative, you are losing an electron. So when you remove an electron, you are oxidized, which means you increase in terms of your oxidation number. That's what we are referring to, say a substance that loses electrons is oxidized because its oxidation number increases. But the substance that gains the electrons is now going to be reduced. It's going to be reduced because it's gaining an electron, and then when you gain negative, you are reduced. So it's important. We talked about the anode. We said an ox. We said it's an electrode where oxidation takes place, and the cathode, we said it's an electrode where reduction takes place. Red cat. Please don't forget that. When you have a red cat, you know that that is at the cathode where we'll have reduction. When you're having an ox, you know that that is at the anode where oxidation, which is loss of electrons, occurs. So now, with no wasting of time, we are in your question papers. You are going to get this data sheet, which we are going to use to calculate the EMF of a cell, which we are going to talk about. However, I want you to employ or to use this data sheet in order for you to remember some of these definitions. Remember, I said a cathode is an electrode where reduction takes place. So in the data sheet, you know that already that when we have a cathode, is an electrode where reduction takes place. So you can see that already that helps you to remember the definition. The same with the anode. We are saying Where we have an anode is an electrode where oxidation takes place. So you can use this data sheet to remind yourself of those definitions. And then when we say what is an oxidizing agent, remember we said it's a substance. The main thing you are saying there when we talk about agents, you are saying it's a substance that undergoes reduction. A reducing agent is a substance that undergoes oxidation. So you are able to use these formulas to remember all these definitions. Then we know that in terms of definitions, you will always give us correct answers, and you will utilize this data sheet for that. I just made a small mind map there to say this is the focus in terms of grade 12. Your focus is, remember we're talking about question 8 at the end of the year, which is your galvanic cell, and question 9, which is your electrolytic cell. And we're saying for galvanic cell, the things that you must know is those that I talked to you about, to say you must know what is oxidation, which you said is loss of electrons. So you remember that a loss of electron is oxidation. Please remember that at all times. We're saying gaining of electrons is reduction. And we are saying anode is an electrode. Remember we said an ox is an electrode where oxidation occurs. So we said oxidation is loss of electron. So where we have in the anode, there must be loss of electrons. Where we have a cathode, there must be gaining of electrons. We indicated. So we said a reducing agent goes with this one. It's a substance that undergoes oxidation. We said an oxidizing agent is a substance that undergoes reduction. Please remember that at all times. You must know now what is an electrolyte, because we will be using an electrolyte, which is a solution now, a solution that conducts electricity. So we're saying when you have a substance, most of the time you have done what we call hydrolysis, which is a reaction of salt and water. So that's the main idea here, to say whenever a solution, when we have a substance that is dissolved in water and it gives a solution that conducts electricity. So an electrolyte is that solution that conducts electricity. Then we are saying that we refer to that as an electrolyte. So when it's an electrolyte, you can see that it's a substance is dissolved in water. When that happens, it gives rise to a solution that conducts electricity, and we refer to that as an electrolyte. So we're going to look as well the relation of current and potential difference to the rate and equilibrium. So we still talk about equilibrium. You will have seen that most of our in this table of standard reduction potential, we are given that sign that we use for equilibrium for reversible reactions. So say we have two reactions and those reactions are at equilibrium. So we'll talk about equilibrium under this topic as well. And then you have to understand the processes and their redox reactions as well. So if you know all this, you know that you are well to do for question 8. Now, let's look now at oxidation numbers, because we want you to be able to look at a question paper and say, I can answer this question even by merely looking at the oxidation numbers. Because when you know oxidation numbers, you will look at the question, you will see which one is losing electrons, which one is gaining electrons. So just to remind you of the oxidation numbers that you have done in grade 11, to say they are still very much useful here, and utilize them to answer the question. So what are we saying? We're saying focus on oxidation number for compounds, ion, and elements. Remember when I started, I said all these three, we're going to refer to them as substances. So our substance, we can have a compound, we can have an ion, we can have an element. We must be able to know the oxidation numbers of all of them. So that is what we're going to do in this slide, and I hope it will help you as you remember how to assign these oxidation numbers in order to determine which substance is undergoing oxidation, which substance is undergoing reduction. Remember, we call this redox because it's a reduction reaction and oxidation reaction. Redox comes from the reduction, oxidation reaction that involves the electron transfer. When electrons are transferred, there will be loss of electrons. When you lose electrons, there will be loss of electrons. When you gain electrons, you will have a reduction that takes place. Now, what are we saying? We are saying, let's look at the rules. We put most important rules first. So we in this slide, I'm trying to show you in terms of the order, in terms of which one is more important. For example, the first one that is very much important is a neutral compound. When you're having a neutral compound, all oxidation numbers must add up to 0. For example, we gave you the carbon dioxide, CO2. CO2 2. So what we have to check there, remember oxygen is in group 16, and I showed you that group 16 elements, they are more likely to form -2 as their charges, which means gaining of 2 electrons, because they are in group 16, or they are running short of 2 electrons to be fully filled. Remember, we're saying that the octet rule, we want to have 8 electrons in the outermost energy level. So if you check group 16 like carbon, you'll see that they have 6 valence electrons. So the more likely is that oxygen would like to gain 2 electrons, and when it gains 2 electrons, it becomes -2. Hence, we assign the -2 on the oxygen there to say oxygen is -2. So if we check the rule, it says that a neutral, it must add up to 0. As long as it's neutral, it must add up to 0. So if you have -2, but you have 2 oxygens there, which means this will be -4, which means to get 0, you must have +4, which means carbon will have oxidation of +4. So always remember that rule that applies when we have oxygen, more likely to be minus. Always, we say almost always, oxygen will have -2, almost always, because there will be small exceptions to that rule. So you go to understand, when you see oxygen, you know it's always almost -2, hence the carbon becomes 4, so that when you add +4 and -4, they give you 0. So you're able to understand how to assign those oxidation numbers. Now let's look when you are having an ion. We're saying when you have an ion, whether an ion, we're saying the numbers must add up to the charge on the ion. So, for example, we gave you the sulfate ion there, SO4 2-, which means at the end of the day, when you add them up, your answer must be -2. Remember, you have 4 oxygens, which means 4 times 2. 4 times -2 is -8. But you want your answer to be -2 because they must add up to the charge. So the final answer must be -2. Hence, we're saying when you have -8 there for that oxygen, there to get -2, you can simply say -8 you can simply say x -8, x for sulfur, -8 for oxygen. The answer must be -2. Then you can solve for x, where you are saying x will be equals to -2 plus 8, and that gives you +6. So you know that for sulfur, the oxidation number will be +6, because the final answer must always add to the charge on the ion, which is -2. So I hope you got that and you would utilize that. Remember, we're going to apply this on questions so that you know how to utilize the oxidation numbers to determine whether oxidation is taking place, redox reaction is taking place. Now, oxidation number is not ionic charge, but they do overlap. So that is something that is worth mentioning. But we're saying free elements, like the elements that you see on the periodic table, we're saying those ones, their oxidation number is 0. So if you just see an element that is just alone, you know its oxidation number is 0. For example, if you see sodium alone and you see iron like that, which is not bonded, which is just an element. Remember, we said an element cannot be broken down, but immediately when it's joined to others in a specific ratio, we said it's a compound. So when you say element, we're saying these ones, their oxidation numbers are 0. Now, this includes diatomic molecules like hydrogen and oxygen. So it applies as well to diatomic molecules, those which go in pairs. We are saying that when they are two like that, their oxidation numbers are 0, 0 in that way. Now, let's look at group 1. I've already indicated this. I said group 1, where you have sodium, they can lose 1 electron because they have 1 valence electrons. The group 2, they can lose 2 electrons. The group 13, where we have aluminium, we can lose 3 electrons. And then we indicated that hydrogen, when it bonds with non-metals, and then the hydrogen will be +1. You see, hydrogen is +1 because chlorine is group 17 and it's more electronegative. So it is the one that must gain the electrons. Hence, we are saying it pulls more electrons towards itself because it's more electronegative. Hence, it will be -1 for chlorine and +1 for hydrogen. But when you have a hydrogen with metals like boron, for example, a hydrogen can take a -1. But these are very much too much of exceptions that to the rule that hydrogen is a +1. Most likely, hydrogen will give you a +1, except if it's going with those metals, which is not likely most of the questions that we ask you. Now, oxygen -2. With the exceptions with fluorine or peroxide. It's only in these structures of oxygen and fluorine and oxygen and peroxide in the H2O2, the hydrogen peroxide. We are saying now the rule does not apply only there, but oxygen will almost always be -2. Then the only time oxygen will be positive is it will be different from that -2 is on the OF2 and the H2O2 there. Now let's look at group 17, which is your halogens. You are having your fluorine there, you are having your chlorine and bromine, those halogens. We are saying they are most likely to gain an electrons, hence they will be -1. Group 16, where we have oxygen, we said -2. Group 15, where we had nitrogen, we said -3. So I think these oxidation numbers will help you as you answer questions. Now, with no wasting of time, let's look at a question and be able to see whether you can be able to respond to questions when they're asked in the exam. So we took these questions from your previous exams so that we are able to check whether you are ready to write this type of assessment. Now the question is saying, consider the reaction below. So you have a reaction to supposed to be below, it's just a side. So we're saying zinc plus copper sulfate forms zinc sulfate plus copper. Which substance is the oxidizing agent? This is a beautiful question. It's something that you must always practice so that you remember all these definitions that we're talking about. Remember, by definition, we said loss of electron is oxidation, which gives us the reducing agent, which is oxidized. But gaining of electrons, we said, is reduction. That gives us an oxidizing agent that is reduced. So in this one, they're talking about oxidizing agent, and by definition, an oxidizing agent is a substance. We said it's a substance that undergoes reduction. So we want that substance that undergoes reduction. And the other tool that you must know, the agents are always on the right of the reaction. So it means on the left of the reaction. On the left of the reaction, we have a strong reducing agent and a strong oxidizing agent. You must understand that at all times. So when you're looking for a reducing agent and oxidizing agent, you will go to the left of this overall reaction to say the reaction is always between a stronger reducing agent and a stronger oxidizing agent. So you got to look there and say, okay, zinc as its own, a metals on their own, they are most likely to be your reducing agent. That gives your solutions because they have ions. Remember, oxidizing agents, we said that oxidizing, they must be reduced. So you must be having something that can be reduced from you. So if you see a zinc, which you said it has an oxidation number of 0, so the likelihood of reducing it further is not there. The likelihood is that you can increase its oxidation numbers, because when we're doing the issue of oxidation numbers, we're saying zinc, a free element, has oxidation number of 0. But in a solution like that, you will go through all that trouble of saying you have oxygen, which is your -2, that will give you -8. And we said this must add up to 0. So if oxygen is -8, you will check that, okay, copper, you have copper and sulfur. They must give you, the answer must be 0. So between the copper and the sulfur, you know copper is a copper 2. So that will be your +2 for copper. That will say that for sulfur, it must be +6. 2 plus 6 is 8. 8 minus 8 is 0. Remember, copper sulfate is a neutral compound. If it's a neutral compound, it must add up to 0. So we're able to know that, okay, by using the oxidation numbers, copper will be 2, and then sulfur will be 6, and then that will be -8. That will be like that. So in this case, we're having a zinc here, that is 0. We're having a copper here, that is +2 on this. So we have copper 2 plus. In this reaction, we have zinc plus copper 2 plus forming. We have a solution sulfate. Already we talked about it, or is an SO4 minus. Is our solution, that one. Now we are saying that gives us zinc sulfate. Zinc sulfate. Same here, it's giving us zinc 2 plus. So if it's in an aqueous solution, you know that that's where we have our ions. So it's giving us zinc 2 plus, and then you're able to see. So these salts that have SO4, you know, is SO4 is SO4 2 minus. So it's very important that you know that when I see something with SO4, copper sulfate, it must be Cu2 plus for this one, because when you add the charges, they must give you 0 there. So it's important you know that zinc is becoming zinc 2 plus, and then plus copper. So you are able to look at it this way to say, okay, what is happening to zinc? Zinc is undergoing oxidation. Remember, oxidation, we said it increases. So zinc is undergoing oxidation because it's increasing in oxidation number. But when you look at copper 2 plus, it's undergoing reduction. Why? There's a reduction in there. Remember, from plus 2, here it was plus 2, but when it's on its own is 0. So you're able to see that from 2 to 0, that is a reduction. So you're able to say, okay, zinc is undergoing oxidation, which is loss of electron is oxidation, which means that zinc is a reducing agent. So zinc is a strong reducing agent. It's reacting with copper 2 plus, which is copper sulfate. So copper sulfate is showing that that is copper 2 plus. The copper 2 plus is becoming copper, which is 0 here. So you can see that copper 2 plus is undergoing gaining of electron, which is reduction. So copper 2 plus is your oxidizing agent. So what am I saying to answer this question? I'm saying you will know that the metals on their own, without the ions, without being in aqueous state, we are saying that they are mostly more likely to lose electrons. That's what I said when we're dealing with the periodic table. So you will know that these are reducing agents. You will see when we look at the table 4a or table 4b, it will show you that you will be having this reducing agent on the right of the table 4a and table 4b, and then these ions you will be having them on the left of your table, and then that we refer to them as oxidizing agents. So you got to know that oxidizing agent is B and C, but zinc and copper are reducing agent. And the question is saying, consider the direction below. Which substance is the oxidizing agent? So our answer is either B or C, because oxidizing agents, you see them there, they are in aqueous solutions there. Now, you can see that we're having oxidizing agent, but I indicated that the agents are always on the left of the reaction. So you will know that we have zinc, which is a stronger reducing agent. It's reacting with copper 2 plus, which is a stronger oxidizing agent. So strong oxidizing agent is copper 2 plus. How do we know that is copper 2 plus? Because copper 2 plus is on the reactant side. It's on the reactants there. So you got to know that your oxidizing agent always on the overall reaction, on a reaction like that, will be in your reactants. You will be having stronger reducing agent reacting with stronger oxidizing agent. I hope that will help you going forward. So you're able now to identify which substance is the oxidizing agent is copper 2 plus, because oxidizing agent, we said it must be reduced. So you see that copper 2 plus is reduced to copper. But if you say zinc, you will be wrong, because zinc is oxidized to zinc 2 plus. So I think I've explained it. I took my time to ensure that you remember that, and forever you will remember that and be able to collect marks. Now, let's look at your papers that you responded to in your previous grade, because this information that you are bringing from your grade 11, they are very much important for this topic, so that you are able now to understand, to build from known to unknown. We don't want to just take you to something that you know. Whatever we're talking about is something that you know you have done, but you are utilizing it to answer the questions that you are doing. We're saying there's a reaction between the permanganate ions and hydrogen sulfide is given below. Define reduction in terms of oxidation numbers. You see, we can put you in a small corner there to say use oxidation numbers to answer this question. So you cannot say loss of electrons. You can say loss of electron is oxidation. It's correct, loss of electron is oxidation, but they said according to oxidation numbers, because this is according to electron transfer. So if they say specifically oxidation numbers, you will define according to oxidation numbers. I have shown you with copper, it was copper 2 plus, it became copper, and then we said this is reduction from 2 to 0. So you're able to say that a reduction in terms of oxidation number is the decrease in oxidation number. When the oxidation number decreases from 2 to 0, we call that reduction. So reduction in terms of oxidation numbers means decrease in oxidation numbers. So, but don't forget, if we talk about a reduction in terms of electron transfer, you're going to say gaining of electrons is reduction. So in terms of electrons, you will say this. In terms of oxidation numbers, you'll say it's a decrease in oxidation numbers. So that's how you were dealing with it. And determine the oxidation numbers of manganese in the permanganate ions. So you are given all that, and you have to know that your answer there must be -1. So you got to know that you have MnO4 minus, and then your answer must be equals to -1. So for oxygen, we said it's almost always -2. So you know that you have -2 times 8, which will give you -8. Then you want a number that will give you -1. So you can simply say x equals to -1 plus 8, which is equals to +7. So you know that the oxidation number of manganese there must be +7. So you can check that, okay, that's what is happening. Now here's a question which is saying write down the formula of a substance that undergoes oxidation. So it's a question, it's a serious question that you must ponder and think about to say, okay, which substance out of all of this, which ones is undergoing oxidation, increase in loss of electron or increase in oxidation number. You want the one that is increasing in its oxidation number. So you got to go through it all and check which one. You will have seen, you will have had looked at all of them, looked at MnO4. You had there, you had this one was +7, but you can see that Mn now. You remember we're talking about Mn here. We said it's +7. Manganese is +7. So you can see this side, manganese is now +2. That must be gaining of electrons. Remember, when you gain electrons, there will be reduction in terms of the oxidation number. So you are able now to see that Mn is oxidation number is doing the reverse of that. But now if you look there on your H2S there and look at your hydrogen ion, you will see there is +1. But now you are having now very interesting here. This when you come to H2S, it's important. Remember, this is subscript. Is you write H2S like this. Must write it correctly. That's your H2S. Now look at that now to say, okay, when it comes to H2S, hydrogen is in group 1. So you know hydrogen. If hydrogen is +1 times 2, then this one must be -2. Remember, it is neutral. It is neutral. So you have H2S, which is your sulfur there. It's -2. So you are saying this one is 1 times 2, and then we are saying when you add X, which is this sulfur, it must give you 0 because it's neutral. Then you're able to say X is -2. So you know that, okay, sulfur is -2. But let's check sulfur on the product side there. It's now a free element. And we've indicated that a free element will have 0. So you can see that it is the H2S there, the sulfur there, that is now that is undergoing oxidation, or that is increasing in the oxidation number. Why? Because we are saying in H2S, sulfur is -2, but this side, sulfur is 0. So you can see that sulfur is increased in its oxidation number, which means now sulfur is undergoing oxidation, meaning that that is the one that is losing electrons, which now explains our question 2.4 there. To say explain the answer in the previous question, that must read the answer in 2.3 in terms of oxidation. So you will be able to say, okay, in terms of oxidation, it shows that this H2S now is undergoing loss of electron. Sulfur is undergoing loss of electron, which is oxidation. Then this will explain nicely for this equation. Write down the formula for the oxidizing agent. Always remember the process is what will always remind you how to answer a question. Remember, when you talk about oxidizing agent, you said it's a substance that undergoes reduction. So it's gaining of electrons. Reduction is an oxidizing agent which is reduced. So immediately when you say oxidizing agent, this one must come to your mind to say, okay, oxidizing agent is a substance that undergoes reduction. Already we've indicated that H2S or your sulfur is undergoing oxidation, is increasing from -2 to 0. And then when you look now at manganese manganese was, we said manganese is positive 7. It becomes positive 2. So you can see that now this helps us now to respond. It's okay, manganese, it was 7 plus, meaning it's gaining electrons to become 2 plus. So its oxidation number is undergoing reduction, its oxidation number is decreasing. And if it undergoes reduction, we said it's an oxidizing agent. So that is our manganese there. Write down the oxidation half reaction. So oxidation is loss of electrons, not gaining of electrons. So we said it's H2S that is going to lose those electrons, which in this case 2 electrons, and then it's going to form now your product now that is now running short. If I use S, for example, I'll say we are having S2 minus, that loses 2 electrons to become S plus 2 electrons. Then you're able to see that it was S2 minus was in the H2S, is the one that now lost those electrons, and then it became S. So that helps you to write the oxidation half reaction. The last question was use the ion electron method and write down the balance net ionic equation. All this prepares you. Go look at those question papers, look at question like this one on redox reactions. As you revise, it will be helping you to remember all this which we are doing. Now, you will have seen our 2.6, which we had our H2S now, which we're indicating, or now we're forming a sulfur and 2 electrons are being lost. Don't forget to include the 2 hydrogens that we had there. But the main focus now was on the sulfur because it was -2, now is 0. So you can see that there is oxidation, there is increase in oxidation number. But when it comes to hydrogen, it was +1. It is still +1. So there is no change in terms of the oxidation numbers. So we can't say it's undergoing redox. So you're able to do that. The last question, which we are saying balance net ionic reaction. So you will write this one, which is your loss of electrons. So you write this, which you refer to as oxidation half reaction. So you write oxidation half reaction, which is your loss of electrons, and then you write your reduction half reaction, which is your gaining of electrons. So you can see with the electrons on the left and electrons on the right for oxidation, reduction half reactions. So you add the 2 reactions to get the net. We call this net or overall. Please understand this. You are going to help you in terms of getting those 3 marks there. To say, please ensure that you first, before you write the net, which is the last equation we're having there, you must first balance the electrons. So you can see that the first reaction, it has 2 electrons. The second has 5 electrons. So you must multiply 2 by 5, 5 by 2 to get 10, so that the electrons are balanced. Please have that skill to say, to get balanced electrons, if you have 2 and 5, I'll multiply 5 by 2 and 2 by 5 so that they are equal. Meaning that you don't only multiply the electrons, you multiply the entire reaction. In this case, I'm saying to you, you will say this reaction, the whole of it, you'll multiply it by 5, by 5, by 5, then you get 10 electrons. You get me? And then on this one, you'll multiply by 2, 2, 2, 2, 2, so that you get 10 electrons. And when the electrons are, only when they're equal, then balancing, we cancel the electrons, because on the oxidation, the electrons are on the right, on the reduction, directions are on the left. So you cancel the equal number of electrons. The main issue here is that what is on the left, you must write on the left. So you can see on the left, we had H2S, we had MnO4, we had H+, we have 5 electrons. So you write all that there, and then you are able now to write the 2Mn2+, everything, you write like that. Then you get your balanced equation, and then you are able to get all your 3 marks for balancing this equation. I hope it will help you, but the most important thing, ensure that all your ions are balanced in terms of, more especially the electrons, because most of the reactions you will be doing, you will be expected to balance the number of electrons before you can write the overall or the net cell reaction. Now, we arrive to grade 12. We say, as you enter grade 12 electrochemical cells, this is what we are saying now. We're saying these electrochemical cells, they involve a transfer of electrons. And we are saying energy for galvanic cell, energy is converted from chemical energy to electrical energy. It's important. When you say galvanic cell, you must know it's from chemical energy to electrical energy. The advice that I will give you, because you were busy with we were busy with electrodynamics. You were saying energy is converted for generators, for example. You were saying energy is converted from mechanical energy to electrical energy. So I will advise you to say, we're talking paper two. It's no longer mechanical energy to electrical. It's now chemical energy to electrical. And it's not a generator, it's a motor. But if you look at it, you will see that most of the things that we are generating energy still here. We are producing electrical energy. Even a generator was converting mechanical energy to electrical energy. But in paper two, in terms of galvanic cell, we are converting chemical energy to electrical energy. I hope I've clarified that, and it will help you as you study further. Now we're going to do another cell, which is electrolytic cell, which is not the subject for today. On that one, we'll convert electrical energy to chemical energy, the same way you did with the motor. Remember when we were doing motors, you said a motor converts electrical energy to mechanical energy. So don't confuse them. It's now chemical and electrical, not mechanical. So we don't use mechanical in paper two. Now we're saying an electrochemical cell is a device where electrochemical reactions take place. And we have two types of electrochemical cells that we're going to do is galvanic and electrolytic cell. Now, these are the things that you must know. You will have seen, I've been talking about electrodes. So I've talked about this already. An electrode is simply an electrical conductor. Remember, electrical conductor, you cannot use gas. You cannot conduct your electricity to a gas or to an aqueous solution. So there will be vents where you don't have a solid. When you don't have a solid in your reaction, you will need a conductor, because conductors must always be solid. So it's important that I emphasize that electrodes, which are our solid electrodes, and which must be electrical conductors that connect the electrochemical species with a solution to external electric circuits. So electrode is the first thing you need. And remember, I said there are two electrodes, anode and cathode. The anode, we said that's where oxidation takes place, and cathode, we said red cat, we said that's where reduction takes place. Now, the other important aspect or tool that we need here is what we refer to as an electrolyte. Remember, the electrolyte, we said, is when a substance is dissolved in water and it gives ions that conducts electricity. It gives rise to ions, and those ions gives rise to a solution that conducts electricity. That solution that conducts electricity, that's what we refer as an electrolyte. So you must have it in your mind that you will need two electrodes, which is the anode and the cathode. You will need the solution that you are going to put your anodes in so that you can complete your circuit. We'll talk to that when you start. So you see that is your electrolyte. Now, with no wasting of time, galvanic cell, which is your focus, we are saying now this one converts, I told you already that it converts chemical energy to electrical energy. So please, that's your 2 marks. You must know. Define galvanic cell. You say it's a cell that converts chemical energy to electrical energy. And we're saying this cell is a very special cell because it's spontaneous. It means no energy is added. In fact, it produces energy, it releases energy, it's exothermic. So it's important that you know that this is exothermic, which means it releases energy. It doesn't absorb it, it releases. That's why we're converting chemical energy, we're producing electrical energy. So those are the 3 most important things that you must know with galvanic cell as you start. I've already indicated that we are going to have our 2 different metals, each immersed in a separate beaker containing their respective metal ions and solutions. So we are saying that in this case we'll have 2 different metals, and then which are our electrodes in that case, which must be solid, which we are saying they are good conductors of our electricity. And then we are saying these 2 must be having immersed in 2 beakers. So you're expecting that we will have 2 beakers like that, and we're going to have an electrodes, the other one anode, the other one cathode. I don't want you to think that anode and cathode, the other one is on the left, the other one is on the right. When we start with the section, I want to emphasize to say we can put anode either on the right or the left of the two beakers. So you don't have to cram to think that anode is always on the left. No, sometimes we put anode on the left, cathode on the right. The main thing is the reaction that is taking place. So we are saying we have that. We have the two beakers, and then in those two beakers, we have two different metals that we immerse inside the solution. So we're saying inside here, we'll have a solution that I refer to as an electrolyte. So we'll have an electrolyte, a solution that conducts electricity. We have the solution, we have our electrodes. Another one is anode. I can put anode on the left for this case and cathode there. And remember what I said, we can put them in different ways. It still does not make any difference. So we're able to do that. We're able to have that, and then we can have a voltmeter here that can read the voltage. And now our cell is incomplete without a salt bridge. So we have a salt bridge, which is now to complete the circuit. I'm giving you the first function of the salt bridge is to complete the circuit. So the circuit is complete when it's like that. So we have two electrodes. They are immersed inside the electrolyte, which you said is a solution that conducts electricity. And we are saying now we must have a salt bridge that will complete the circuit. That is the first function of the salt bridge. We'll talk about the rest as we move with the section. Now, the most popular galvanic cell is your zinc copper cell. Your zinc copper cell, very interesting. You will see that now you are having zinc. What I want you to understand for now, we're having zinc immersed in zinc 2 plus or the zinc sulfate. So when you see zinc sulfate, you know, I told you already that SO4 is a 2 minus, which means zinc is a 2 plus. So you know that the solution we are having, electrolyte, our electrolyte is zinc sulfate, which means the solution, in the solution we have zinc 2 plus and we have zinc metal. So we have two things. We have zinc and zinc 2 plus. So always a metal will be in its metal ion solution. And then we're having this side a metal which is copper, Cu, in a Cu2 plus solution. That copper sulfate, remember, is a copper 2 plus, so that you don't forget that. Then we have our salt bridge here, which we said is to complete the circuit. So the salt bridge is completing the circuit. It means our circuit is complete. Now we are going now to want to determine who between the zinc and the copper, which one, because this cell we're saying is a zinc copper cell, which one will lose electrons, which one will gain electrons. Remember, we said if it's a metal and a non-metal, it becomes obvious for you that a metal is more likely to lose electron, a non-metal is more likely to gain electrons. I've explained that at the beginning of the lesson. But now you are having two metals, a zinc metal and a copper metal. So which one will lose electrons? Which one will gain electrons? Very much important. Now, to determine that, we are saying that if you look on the table of standard reduction potential, those values will show you which one will lose electron, which one will gain electrons. In this case, you will see when I open the table, everything is written as zinc 2 plus 2 electrons forming zinc. They are written like that. You have copper 2 plus, plus 2 electrons forming copper. Double arrow is a reversible reaction. You have them like that. But we have what is called now standard reduction potential. Zinc half cell, it has minus 0.76 volts. And this one of the copper cell, it has positive 0.34. I want you to understand me. How do we move from here? Now, these values are important that we are getting on the table, is because they are telling us that this copper, the copper 2 plus, because the competition is between zinc 2 plus and copper 2 plus, all of them, they want to gain electrons. So we're saying who will gain electrons? Remember, the standard reduction potential, remember potential is the ability to gain electrons. So we're saying, sorry for that, we're saying the ability to gain electrons, who has a bigger ability? You can compare minus 0.76 and positive 0,34. You will see that positive 0,34 is higher standard reduction potential, which is a higher ability to gain electrons. So the one that has a higher ability to gain electrons will gain electrons. Hence, we are saying between zinc 2 plus and copper 2 plus, copper 2 plus will gain electrons. Why? Because it has a higher standard reduction potential of 0,34. So the first way you can use to determine which one will gain electrons, you can use the standard reduction potential that are given on the table. You are able to check that the one with the higher standard reduction potential will gain electrons. Hence, when we write the half fractions here, you will see that zinc loses electrons. So when it loses electrons, we write only one arrow. Remember, on the table, they were all given as two reactions, which is zinc 2 plus 2 electrons forming zinc, and you had copper 2 plus 2 electrons forming copper. And then we're saying because this one, the negative 0,76 is a lower standard reduction potential, it must lose electrons, which means you must reverse it. It must be reversed. But the one that has a higher standard reduction potential, you write it as is. Remember, as you write in your books, you write only one arrow because you are saying it's no longer a redox now. You are writing oxidation, loss of electron is zinc that will lose electrons because it has a lower standard reduction potential. And copper 2 plus will gain electrons because it has a higher standard reduction potential. I hope you got that. So when you write the oxidation half fraction, you will write this one that is on your table, that is the having a lower standard reduction potential will lose electrons. The one with the higher standard reduction potential will gain electrons. And then when you have done that, we are able now to bring the two together to say we can now take the two and do what we call our overall cell reaction, which now we said the first thing you look at the balanced electrons is 2 and 2. So when the electrons are balanced, they can cancel, and what is on the left you write on the left. Remember what I said on our when we started the equation. I said on the left of the overall or net cell reaction, we are having stronger reducing agent and stronger oxidizing agent. The oxidizing agent, you see there, it has that 2 plus, it shows it's in aqueous solution, but the metal itself is a stronger reducing agent. So you are able to see that we have a stronger reducing agent reacting with a stronger oxidizing agent to form a weaker oxidizing agent reacting with a weaker reducing agent. So on the right, we have the weaker ones. On the left, we have the stronger ones. So you got to have that understanding to say, okay, zinc will lose electrons. Remember, when zinc loses these these electrons are moving now from this side going to that other side. So what happens is that as zinc loses electrons, it's leaving zinc 2 plus. Zinc 2 plus is the solution. So which means you're expecting this solution to increase. So this side of the anode, you are expecting the zinc sulfate solution to increase. Why is it increasing? It's increasing because zinc is losing 2 electrons and becoming zinc 2 plus, which is the solution. So the electrolyte will increase. The concentration of the electrolyte will increase. However, where the electrons are going, when the electrons come this side, they find copper 2 plus in the solution. They get this copper 2 plus, which is our solution there. And we're saying these 2 electrons are going to react with copper 2 plus to form copper. So the 2 electrons, they move this side, they react with the solution, they form copper. So then most likely you will see that our cathode, because remember where we have red cat, we said red cat, where we have reduction, we said is the cathode, and we said an ox, where we have oxidation, we said is the anode. So on the anode side, you will see that the mass of this zinc that is losing electrons decreases. So because zinc is losing electrons, its mass will decrease. But what increases is the solution of the electrolyte. The solution of the electrolyte will increase. The concentration of the electrolyte will increase. This side as well, the copper 2 plus, the solution of the electrolyte will decrease. Why? Because copper 2 plus, which is the solution, the electrolyte, is reacting with the 2 electrons that are lost by zinc to form copper. So you are most likely to see that this copper will increase in mass. So you're expecting that copper will increase in mass. When it increases in mass, its solution of the electrolyte decreases. So you see there are two things. what decrease here is the mass of the anode. What increased this side is the solution, the electrolyte itself. But on the other side, we're saying what increases here is the mass of the cathode, and what decreases there is the solution itself. So I hope you got that. Hence, we're saying it's important to have this salt bridge. So this is what we are referring to as a salt bridge. Remember, it has two functions. The first function I said is to complete the circuit. So we're completing the circuit. And how does it do that? It maintains electrical neutrality. What do you mean, sir? I mean that when zinc loses electron and becomes zinc 2 plus, we're having a lot of positive here, charges here. Hence, the N ion from the salt bridge, we have a salt there. Hence, we're calling the salt bridge, which in this case is potassium sulfate. The SO4 2 minus will come this side to neutralize the zinc 2 plus that is being formed. So hence we're saying function number 2 is to maintain electrical neutrality, and then function number 1 was to complete the circuit, which is an exam question to say what is the function of the salt bridge. We're saying it completes the circuit and it maintains neutrality. I hope you got that, and it will help you as we move forward. I just wanted to emphasize here to say, remember, we said where we are having a lower standard reduction potential, in this case on the zinc 2 plus side, we are saying now that one is now going to be an ox, which means oxidation is loss of electron. So we're going to have loss of electron, which is oxidation, meaning that this reaction, you're going to write it backward. So just wanted you to think that even in the past, people used to use the ox to trade and all that. So when you look at the past, an ox will remember you that you are going backward. But now we are simply saying that an ox, the reaction is going backward. Hence, I've shown you that when we have a lower standard reduction potential, that is an ox, it means that that is an anode, and that's where oxidation takes place, which is what? Loss of electron, which is oxidation, which is our reducing agent, which is oxidized. So the reaction is going backward. But you will see that at the cathode itself, we're talking about the red cat. I think these are the cats of the future. We're going forward, and then we're saying red cat, it means that is the cathode. At the cathode, that is reduction. So you can see where we're having a higher standard reduction potential, that is our cathode, and then where the cathode, the reduction takes place. I always want to make you to remember that A comes before C. So if you look at table 4b, because you have two tables, at table 4b, you will see that you have the anode as negative, and then cathode comes that. So if you are using table 4b, you are able to identify that which is at the top of that particular table, it will be your anode. That which is at the bottom will be your cathode. Depending that you are using for galvanic style table 4b, it becomes easier. But I'm not saying cram it. I'm saying just know that the cathode is that one which has a higher standard reduction potential, and the anode has a lower reduction potential, as you can see those values with you. So all the time when you're dealing with this question, ensure that you move with it. Ensure that as you move, you are able now to have the table always with you, because it will always guide you and show you that as you go forward, you are having red cat, and then you are able to remember all these reactions. And then I just use those clips that we're having for power there to show you that we have a positive. Remember, red is positive. So the positive one, that is your cathode. So you know that the positive one is my cathode, and then you are able to see that, okay, cathode is positive and it's red. So it helps you to remember that, oh, the red one is the cathode and it is positive. And if you can see there, you are having minus 0.76, comparing it with positive 0.34. So the positive one, that is your reduction, and is your cathode, and you are able to see those. And then they are able to, as you use your batteries, you know that the red is positive. So don't forget, red is positive, which is the cathode, red cat. So you remember at all times. The black one now there, which is our anode, you are able now to say, okay, we're having the black there, which is our anode, that is working as well as your negative, the negative one, negative anode. You are able to see that we go back, the reaction must be loss of electrons. And for the cathode, it must be gaining of electrons because it has a higher standard reduction potential. I think I was able to win you, and we're moving forward together, and you will do well in terms of this question, and you will always remember this which we talked about. I've already indicated to yourselves how to write the overall cell reaction, because we said you first indicate. If you look here, I wanted to do the explanation nicely here. These arrows are still two arrows there. That's how they appear on the table. You have two arrows. You have the one going forward and the one going backward. That's how the table gives you these values. You have zinc 2 plus 2 electrons forming zinc. You have copper 2 plus 2 electrons forming copper. And then you see the standard reduction potential is negative 0.76. So that's what we will expect of you to say, okay, fine. In your question paper, when you're still practicing, have them like this. Write them the way they appear. I think these ones, we took them from table 4b, because on table 4b, you see that we always start with the negative and then have positive. On table 4a, we start with the positive and having negative. But if for this lesson, I'm using 4b for galvanic cell, just to have you so that we can move together. So in table 4b, you'll see that zinc 2 plus, which is negative, there is at the top of the table, and copper 2 plus is at the bottom in terms of that. Now, if you look there, we have two reactions, which is the forward reaction and the reverse reaction. We want to decide which reaction they will undergo. I've already said you have to reverse one of the half reactions into an oxidation step so that the difference between the E values will be positive. So that is very much important. So, okay, one must be reversed here. Which one? Which one? How do we know which one will be reversed? Look here, we're saying the copper 2 plus copper cell, this one, the copper 2 plus copper cell has the more positive standard reduction potential. So you can see it's more positive, it's 0.34. So it must be reduction. So it wins because it must be reduction, because why? It has a higher standard reduction potential. It has a higher ability to undergo reduction or higher ability to gain electrons. Hence, this one is going to remain like this with one arrow now, and then you are able to say this is a reduction half cell. Now, we reverse the zinc 2 plus half reaction, but we don't reverse the sign. That's not important. So what are we saying? We're saying this one, we're going to start with zinc now instead of starting with zinc 2 plus. Why do we write it going backward? The negative one, it must now lose electrons because it has a lower ability to gain electrons, so it must lose them because of the negative. So that negative one, it will definitely lose electrons because of the lower standard reduction potential. So you will write it now starting with zinc, then it becomes zinc 2 plus 2 electrons. You know, to do the half fractions, you are able now to say zinc plus copper 2 plus. You write what is on the left. Remember, we said step number 1, ensure that the electrons are balanced. It's 2 and 2. If they are balanced, you cancel them. What is on the left, you write on the left, which is zinc plus copper 2 plus. What is on the right, you write on the right, which is zinc 2 plus and copper. So you write that. That is your overall cell reaction, and then you are able to get your 3 marks there. 3. Just imagine you will have 3 marks for writing the overall or the net cell reaction. You ensure that everything is fine, the ions are correct, everything is fine, balanced, and everything, you are getting your 3 marks. Now, calculate the EMF of the cell. I've shown you the formula to calculate the EMF of the cell, which I said is E cathode minus E anode, the one that I was using to show you how to define when we started with the lesson. So cathode is that bigger one in terms of the what we are having there. So you have your cathode minus, we said A, then C. So it's always cathode minus anode. And these values are arranged in this order in table 4b. Now you're able to say 0.34 minus, which is this minus of the formula, minus 0.76. Then you get 1.1 volts, which is your answer. And we give you 4 marks for calculating EMF of the cell. Maybe you're asking yourself, if I write EMF of the cell the way you wrote it here on these 3 steps, look at it there. We're having the oxidation half reaction, reduction half reaction, and overall. Now this side, you write the negative 0.76, positive 0.34, and 1.1. Will you be able to get 4 marks of calculating EMF of the cell? The answer to that question is yes. Now, it means you know that, okay, this one is negative 0.76, but because you are reversing it, you are reversing it. So you will say 0.76 plus 0.34, that will give you 1.1 volts. So we can still give you the 4 marks of calculating the EMF if you wrote in that fashion. However, it's much easier when you just write the formula and you substitute. However, in the memorandum, you'll have the 2 options that you can be able to utilize when you're calculating your your EMF. Now, I've talked to this. It's what I was talking to. Is just emphasis to say you will have oxidation of friction, reduction of friction, net or overall cell reaction, and then you just reverse that 0.76. When you add it to 0.34, it gives you 1.1 volt. You'll still get your 4 marks for writing EMF of the cell. So it's important that you go through that. But if you want to just calculate the EMF, you can calculate. Remember, we said zinc, because it has a negative 0.76 lower standard reduction potential, we said it will lose electrons in this way. If zinc loses electrons, you see what happens? It decreases in mass. So just indicating that. The copper, we said copper 2 plus will gain the electrons. It becomes copper and then it increases in mass. Don't forget, we talked about the solution as well, to say as the zinc decreases in mass because it's losing electrons, its concentration of its electrolyte, which is your zinc 2 plus, will increase. So it's not everything that decrease. Decrease in mass means the concentration of that particular metal ion will increase. And then the increase in mass in the cathode, then it will mean that now there will be the concentration of that metal ions will decrease because it's being is gaining electrons. So it's important that we remember. I've emphasized this one. I said 2 functions of the salt bridge, which is this one. Our salt bridge is to complete the circuit and to maintain neutrality by allowing the movement of ions. Now, it's important here as well for me to indicate that you will remember in the other question, we use potassium sulfate. In this one, we're using sodium sulfate. So we can use different salts. And what you must understand is that a salt has both the positive, which is the cation, and the negative, which is the anion. So you are able to know that you have the cation and the anion. Remember, I showed you that it doesn't mean that zinc as the anode will always be on the left. You can see on this diagram I gave you now, our zinc is on the right. So just to show you that we can put it in way. So zinc is negative 0.76. That is a typo. It's negative 0.76 for zinc, which loses electrons. The copper does like that. Now, I don't want you to forget this. If you can hear me well. We're saying the cation will go to the cathode. So don't forget the positive ion. Remember, cation said it's a positive ion when we started our lesson. The positive ion will go to the cathode. The negative ion will go to the anode. So please remember that at all times to say, okay, the negative one will go to the anode. The cation, the positive ion, will go to that. If you know your salt always, you will always know how to maintain neutrality, because the cation will go to the cathode, the anion will go to the anode. I hope that helps you as and when you answer these types of questions. Remember, I talked about the table to say the standard reduction potential tables. We have 2 tables. They are similar, but the entries are arranged in opposite direction. I've shown you that already. Like this one, it will be table 4A, because the table 4A, it starts with positive, which I said positive, which we said is our cathodes, and then the negatives, which is where we'll find our anodes in terms of galvanic cell. So you will see that it starts with positive ones, and then it comes to them with the negative ones. So you are able to know that that's how it moves. And then how do we use this table? What is the function of this table? These tables were saying we use the table of standard reduction potentials to, number one, to identify oxidizing and reducing agents. Remember, I said to you, on the left, we have oxidizing agents, and their strength increases when you go up. You see the arrow of table 4A there is saying when you go up, you will find a stronger oxidizing agent. When you go down, you will find a stronger reducing agent. So on the right, you have reducing agent. On the left, you have oxidizing agent. At all time, if you are looking for oxidizing agents, you will go to the left of that table. If you are looking for the reducing agents, you will go to the right. Now, if you want to identify the anode and the cathode, you will still come here. Remember, we said I was indicating that you have a cathode is more, it must have a high standard reduction potential compared to the anode. So you can see it's more positive cathode and then the negative on the anode. So we use this table to do that. We can use it to write balance redox reactions. You have seen we're writing balance redox reactions, and we can use it to predict whether a redox reaction is spontaneous or not. I know you got to know when we say spontaneous, we're saying that the EMF of a cell is positive. So when you calculate EMF of a cell, which we said is E cathode minus E anode, we said that must give you a positive, and that shows that it is spontaneous, that energy is not added. So sometimes we say show that this reaction is spontaneous. We are simply saying calculate the EMF of the cell, and then that is the 4 things that you can use this table. You can see that the table of standard reduction potential is very much important, because for you to identify oxidizing and reducing agents, it will help you to identify anode and cathode, to write balance redox reactions, as well as to predict whether a redox reaction is spontaneous or not. And standard reduction potential refer to the half fraction S reduction. I talked to that already, to say we have 2 of them. The other one is gaining of electrons, which is oxidizing agent, which is reduced. The other one is the loss of electrons, which is oxidation, which we find our reducing agent, which is oxidized. I talked to this as well to say what will happen. So obviously we said that will be in our cathode, and our cathode we said is red cat. So you know it's a reduction because it has a higher standard reduction potential. That one we're saying that is in our anode, because our anode is undergoing an ox, which is oxidation. So you're always remembering that and that. I've shown you that even on the left of the reaction, you have a stronger oxidizing agent and reducing agent. I would have hated to finish the lesson without doing an activity. So it's important that we find an activity like this. Now, without rushing this activity, I want you to first do first thing first. When you get an activity like this, the first thing you will do, you will say, okay, we're given copper, we're given copper 2 plus, we're given silver, we're given silver plus. So you got to know that, okay, copper is a metal. So these are by their virtue metals, we said they are reducing agents. They differ in terms of the strength. With the other one is a stronger reducing agent, the other one is a weaker reducing agent. So the only thing that differs between these 2 coppers is that they're all reducing agent. The other one is stronger, the other one is weaker. And the copper 2 plus in our solutions, these are our oxidizing agents, so that you know that, okay, always we are producing 2 reducing agents and 2 oxidizing agents. The difference is the strength of that, and the strength you will see when you look at the table, it will tell you the strength to say which one is stronger, which one is weaker. Now, you can see write down the energy conversion that takes place. Remember, this is a galvanic cell. You will be able to show what will happen in terms of this reaction. And then the second one will talk to the issue of the write down the direction where the N ions will move. Remember, I said the N ions, they always move to the anode. They don't. So the main thing is, if you know the anode, you will know the N ions will move to the anode. And then the third question was calculate the EMF of the above cell under standard condition. Already I showed you the data sheet to calculate EMF of a cell. To say EMF of a cell is given as E cathode minus E anode. So that is E cathode minus E anode. So immediately when we go to the table, we identify the cathode and the anode. Remember, the cathode is the one with the highest standard reduction potential. The more positive one is the cathode. I always say to my learners that this is a bigger number minus that small number. They always give you the correct answer. Don't forget, if your anode has a negative sign, you must be able to substitute that negative sign, so that this negative on the equation, when you multiply to another negative, it gives you positive. And then if you look at the next question, was write down the balance net cell reaction, which is 3 marks, as I was indicating how to get those 3 marks. And then we are saying now if we increase the concentration of silver nitrate, what will happen? So it's important that you are able to answer all those questions. But now, what do you need? You need a table, because a table is going to tell you the strength to say which one is the cathode. Remember, you are looking for that positive, more positive one, or a higher standard reduction potential. It shows you the cathode. The lesser standard reduction potential, it shows you the anode. So you are able with no any problem to see what happens in terms of how we resolve this question. Remember, in terms of energy conversion, we said galvanic cell converts chemical energy to electrical energy. Now, the most important part is the table, because you want to tell us this reaction is it spontaneous or not spontaneous. And we said to do that, you go to the table. And when you go to the table, you're going to find that our cathode in this case will be silver, because silver has 0.80. So you are saying cathode, the more positive one or the highest standard reduction potential. That is our cathode in this case, which in this case is silver. Silver is 0.80, which means this side we're having the cathode, on the left we're having the anode. Remember, on the anode we said we said oxidation takes place, which is loss of electrons. On the cathode we said reduction takes place, which is now red cat. So you are able now to look at this question in this fashion to say, okay, E cathode minus E anode. Please copy the formula as it appears on the data sheet. Don't make shortcuts, because we don't mark, we will always not mark something that has changed, because your responsibility is to go to the data sheet and identify the correct formula and write the formula. We give you 1 mark for that. When you write now for the cathode, which in this case is silver, you wrote 0.80, we give you that 1 mark. And then for copper, which we're talking about, it was positive 0.34. You write the minus of the formula and the positive 0.34, you substitute here, we give you another mark for that. Then you simply use your calculator to say 0.80 minus 0.34 gives you 0.46 volts. So you're able to get your answer. On the question that was saying, find out the overall or net cell reaction. Remember what we said? We said the anode is an ox, which means copper will lose electrons. It will form copper 2 plus 2 electrons, which is the first reaction we're having there. On the silver one, remember the ion there in silver is 1. So it must be 1 electron that is gained there. Ag plus an electron forms Ag. What makes this to gain electrons? It has a higher standard reduction potential. I've overemphasized that, because once you have that at your disposal, you will always know which substance will gain electrons, because of the standard reduction potential tells you that if I have a higher standard reduction potential, I will gain electrons, meaning that you will write the reaction as it appears on the table. You are just changing the 2 arrows, you make 1 arrow. Remember, as you respond, you don't write the 2 arrows, you write them with 1 arrow, 1 for oxidation and 1 for reduction. So you are able to do that. But now, to write down the overall cell reaction, remember, we are saying that the electrons here is very much important here for me. So I'll just remove that, because you can see that it's copper instead. So what you must look at that, you must be able to see that we are having copper is becoming copper 2 plus. But we're having silver, but the number of electrons that silver is gaining is only 1, because that's how it appears on the table. So remember, step number 1 is to balance the electrons. So you got to write the 2 there is 2 Ag plus, is 2 electrons forming 2 Ag solid. So when the electrons are balanced, you cancel the electrons. What do you do? What is on the left? You write on the left. So on the left there, we're having copper solid plus 2 Ag plus. On the right, you are having copper 2 plus 2 Ag solid. So you are able now to get your 3 marks now. Remember, this is 3 marks. 1 for the reactants, 1 for the products, 1 for balancing. That multiplying by 2, we're going to give you 1 mark for doing that. Then you are able to see that this is what is going to happen. And you have seen that because our silver was gaining electrons, obviously we said this side, copper, when copper loses electrons, it means the electrons are moving from copper like that, they are going that side. we have copper 2 plus increasing. So the electrolyte here was increasing. But what is happening? The concentration of this electrolyte this side was decreasing. The concentration here was decreasing. And then when that decrease, if we increase the concentration of the electrolyte, then the EMF will increase as well. So hence we're saying our answer there will increase. The only thing that I will say now when I conclude the lesson is to say to you, you see these cells, you see we put a 0 there with something there, that 0 at the top there, is because even the table, we call it table of standard reduction potential. So you see that there is a standard. What is that standard standing for? We're saying all these reactions are taking place under standard conditions. Please don't forget, in the exam, we ask you to write at least 2 standard conditions. And when you write them, except if we say avoid, write only 2 and accept this one, you must write them in this manner. You can start with the temperature of 25 degrees Celsius, or you can start with the concentration, initial concentration of 1 mole per cubic decimeter. 1 mole per cubic decimeter. The last one, the third condition. So there are 3 standard conditions that we talk about. The last one is pressure. The pressure is 101.3 kilopascals. I want to emphasize here so that we move together. Pressure affects only gases. Remember, we're doing chemical equilibrium, so you know that pressure affects only gases. So we don't have a problem. You know that pressure, I'm writing number 3, because in some of the reactions like this one that we're having here, there is no gas there. So you can write pressure of 101.3 kilopascals, or you can just call it 1 atm. I know some of you don't want to write long numbers. You can just say 1 atm. It stands for 1 atmospheric pressure, which is correct. It's a standard pressure as well. So I hope you understood me. We are saying we're going to write temperature first, followed by concentration. But if we just write, we say write 3 standard conditions, and you just write temperature, concentration, and pressure, as we were doing when we were talking about equilibrium. Remember, we're still talking about equilibrium here. We said there are 3 factors that affect chemical equilibrium. You said it's Cape Town, CPT, which is your concentration, your pressure, and temperature. In this case, you can't just say temperature, concentration, pressure. You must say temperature of 25 degrees Celsius, or you can use kelvins. You add, then you get 298 kelvins. Concentration of 1 mole per cubic decimeter, pressure of 101.3 kilopascals. Then you are able now to get your answer. I hope this was a very valuable lesson. Go and look for other activities like this one that we're doing in this lesson, and do it on your own and see where you have problems and all that. And with those words, I will say until we meet again, all the best. Thank you very much.